All right, today I want to talk about evaluating limits analytically, like by looking at the equation of a function. Okay, last time we just looked at a graph and you say what the limits are, but I want to do it by just looking at the equation of a function. This turns out to usually be pretty straightforward. Okay, so the way you do it is, I'm referring to something like this. What is, say, limit as x approaches 3 of x squared minus 2x plus 6. All right. We did all pictures last time, but more often we're going to be doing things like this with equations. Anyway, what is the limit here? Here's the general rule for these sorts of things. General rule: you plug the number in. By the number, I'm referring to this 3 right here. I want to know what are the values of this when x is close to 3. Well, that's, usually that's going to just be the same as whatever the value is when x actually is 3. So you plug the number in, and then I'm going to say, this is slightly informal, but it works most of the time. If nothing weird happens, this is the limit. So what I mean by that is, right in this example right here, I'm just going to plug the 3 in, and you get 3 squared minus 2 times 3 plus 6, which is, that's 9 minus 6 plus 6 is 9. And that's your answer, right? That turns out to be the correct answer. That is the limit of this function as x approaches 3. All right. There's a name for what I'm doing here. This is called evaluating the limit by direct substitution. This is just fancy language for you just plug the number in and that equals the limit. All right. This doesn't always work, but when it does work, that is to say, when you plug it in and you actually get some number, then that is the limit of the function that you're talking about. Okay. Well, how could this fail to work? You should ask yourself, what could possibly go wrong when you're doing this? Well, there are a few things that could go wrong. What could go wrong? Here's one that something a little weird happens, right? How about this? Limit as x goes to 2, x plus 3 divided by x minus 2. All right? In the spirit of just plug it in, what should we do? Just plug it in. That is, you plug in 2 for x over here. What do you get? You get, so I'm going to plug in, that says plug, x equal 2. What do you get up here? You get 2 plus 3 divided by 2 minus 2, which is 5 divided by 0. Anything wrong with that? Yes, there is something wrong with that. Dividing by 0 is not allowed. There's no such thing as dividing by 0. So this is bogus for some reason. You have to figure out what's supposed to happen in this case. Well, actually it's not so hard to figure this out, and there's a general rule for this. So this is a rule which you should, I suppose memorize, although it's not hard to remember this. If you plug in and get something like a constant over 0, which is what happened here, where the thing on the top is not 0. That's what happened here. 5 over 0 or 8 over 0, whatever. Something just not a 0 on the top over 0. Then here's what happens. The limit does not exist. That's because what it means when you get something like 5 over 0 is your function is behaving near that point. It means your function is behaving something like this function, f of x equal 5 over x, where you're trying to plug 0 into the denominator. It's a plug. What does 5 over x look like, though, near 0? It looks like this, right? It looks just like 1 over x, only it's multiplied by 5. Okay? And this function here has no limit when x is 0. Okay, so if you get a 0 on the denominator but something else on the top, then you just say the limit does not exist. And that's all there is to it. Okay, what else could happen? Well, if you were looking carefully at what I said there, I said something divided by 0 where the thing on top is not 0, you can immediately say the limit does not exist. But what if they're actually both 0? So if you get 0 divided by 0 after you plug in. Actually, in this case, you cannot just say the limit does not exist. This actually has a special name. Well, let me just finish my sentence here. If you get 0 over 0, this tells you nothing about the limit. All right, it may be that the limit does not exist. It may also be that the limit does exist and equals, you know, some number, right? Actually, this doesn't say anything, and you have to do some more work when this happens. This is kind of the worst case because not only you don't know the answer, you have to do more steps to figure it out. All right. Here's an example like this. Well, let me just say what should you do in this case? If you get this, it tells you nothing. In such a situation, you should go back, simplify more, and then try to plug in again. All right, that's what you have to do. All right, let's try the limit as h goes to 0. H plus 3 squared minus 9 divided by h. How do you like that? I'm using h instead of x. This is, you know, in keeping with most math textbooks. They just decide to change the names of the variables at random for no apparent reason. That's cool. I mean, it doesn't matter what you call the thing anyway. Okay, how do you begin such a problem? You should always start by just try to plug it in, right? So I'm going to try to plug in h equals 0, and what do you get? Upstairs you get 0 plus 3 squared minus 9 divided by 0, right? I plugged 0 in everywhere for h. And I have a 0 on the bottom, so something fishy's going on here. What about on the top? Well, 0 plus 3 is 3, so this is 3 squared minus 9 divided by 0. What is 3 squared? That's 9. 9 minus 9 is 0. So actually I get 0 over 0. This is the scenario that I was just referring to. What do you do if you get 0 over 0? You've got to go back and try to simplify. After hopefully simplifying some stuff, then you try to plug in again. So that's what we're going to do. So this stuff, I mean, it's important that you do this, but it's sort of irrelevant for the rest of the problem because we're going to start over again and try to simplify. What can you do to simplify that right there? You should try to cancel out whatever you can, although there's nothing really that you can cancel immediately as written here. What you can do though is expand this thing. You do like the FOIL, right? I mean, you multiply out. H plus 3 squared would be h plus 3 times h plus 3, right? And you get something or other. You get h squared on the front. On the inside you get 3h, on the outside you get 3h. That's the thing I'm talking about. So let's do that right here. This whole limit is, all right, it's still, I'm not doing the limit yet, right? I'm just simplifying this over here. Eventually I'm going to take the limit by plugging in, but I'm not ready for that yet because this is what happens if you try it at this point. I'm going to replace h plus 3 squared by the results of this FOIL, which would be h squared plus 3h, that's the outside term, plus the inside term is 3h, plus 3 times 3 is 9, right? And then, okay, that was just this part. Now I have minus 9 still there, and all divided by h, all right? Having done that, can we simplify anything in there? Well, the 3h and the 3h can combine. Give me 6h. Put that down here. Okay, the h squared actually can't combine with anything else, so I'm going to leave the h squared. Like I said, these I'm going to turn into plus 6h. How about the 9 and the 9? They cancel, right? So this is plus 0. I'm not going to write that. Divided by h like so. All right? Now, what can we do? Well, we basically want to cancel out h in the fraction here. The appropriate way to do this is on the top, I'm going to factor out h. So it says lim h goes to 0. H times, what do you get when you factor the h out here? You get h squared. You pull the h out, you get another h, right? One h left over. There used to be 2 here. And then over here, plus 6h just turns into plus 6 because I'm pulling the h out. And on the bottom, h. All right, almost done here, but I'm out of room. Give me a moment. All right, What are the b? How can you simplify here? Okay, now that the h is factored out, I can really straight up cancel those guys. And we get lim h goes to 0. All that's left is h plus 6, okay? Now, you can't simplify that anymore. But, remember what we were doing here. We got 0 over 0 at the beginning, so we had to go back, simplify, and then plug in the h again. And hopefully it'll work this time, and it will work this time. I'm going to plug in h equals 0 here, and you get 0 plus 6, which is 6, and that's the answer. The answer is 6, all right? Notice I wrote this lim h goes to 0 every single time. That's because this is an operation, right? It says I'm going to somehow figure out what this value approaches when h goes to 0. And you should be writing it every time until the very end when you plug it in. Now this is actually the value of the limit, right? So some people, I don't know why, but there's some lim haters out there who just, they don't like to write this. This is a real operation, and so you should write it in your equations every time, all right? There's my answer, 6. All right, let's try just a couple more examples here. How about this one? Limit as x goes to -3 of x squared plus 5x minus 6 over, sorry, I meant plus 6 up there, over x squared plus 6x plus 9. All right? Let's do it. As we did before, you know, the first thing you should try is just plug this number in here. If you get a real number as the answer, then that's the answer, and, you know, back away slowly, right? You're done at that point. But let's try it. So I'm going to plug in -3. I'm plugging in everywhere for x here. -3 squared plus 5 times -3 plus 6 divided by -3 squared plus 6 times -3 plus 9, right? What is that? You just work these all out. You get this -3 squared is 9 plus 5 times -3 is -15 here, right? So it's 9 minus 15, and then plus 6 over. Here's another 9. Here's a -18. Here's a 9 plus 9. What do you get? On top, 9 minus 15 plus 6. That's actually 0. And on bottom, oh, are you shocked? 0 again. 0 over 0. That means I got to go back and do some more work. Here's a little secret that I'll let you in on. Most of the examples that we're going to do in our class will give you a 0 over 0. That's because any other example is kind of easy, right? You plug it in, whatever that is the answer. I want to make you work for it a little. So I'm usually going to make it 0 over 0. That's not a promise, you know. Sometimes I'll, just to change it up a little bit, I might not do that, but you shouldn't be surprised if this happens. Okay, what do you do when you get 0 over 0? It means you got to go back, simplify some business, and then plug in again. So let's do it. What are you going to do to simplify that thing up here? Now, in the previous example, we did a FOIL thing. There's no opportunity for that, but you can do kind of the opposite of the FOIL, which is factoring, right? This is something I hope you're into factoring, because it's actually going to be really important in most of the stuff that we're going to do with this business. So I'm going to factor here. So it's still the limit. I'm not doing the limit in this step, of course. You got to factor on the top and also on the bottom. Any master factors out there? What are the factors of x squared plus 5x plus 6? You know, I'm referring to this thing where you go, okay, x and then x here plus something, right? That's what I want. You need to choose these two numbers so that their product is 6 and their sum is 5. And the answer is a 2 and a 3, right? X plus 2, x plus 3. If you're not into this, get into it. You know, this is a really important thing for us. So you might want to do some review on that note. Okay, and what about down here? Down here, it's actually, if you think about it, x plus 3 and x plus 3, right? The 3 and the 3, they need to multiply to be 9 and add to be 6. And so the 3 and the 3 is what you want. Okay, what can you do now? Now that you've factored, you see actually the x plus 3 can cancel on the top and on the bottom. Isn't that nice? I think so. So what it boils down to is this. Limit x goes to -3 of x plus 2 divided by x plus 3. And I have that's quite a bit simpler than what we started with. So let's try to plug it in again, right? Remember the basic strategy. Go back, simplify, and then try to plug in again. See if it's any better. Let's plug it in again. When I plug this in, I get -3 plus 2 I'm plugging in minus 3 for x. Minus 3 plus 3, which is negative 1 over 0. And what do you say with that? This is not an actual number, right? But remember, when you get this after plugging in to find the limit, if you get something over 0 and the thing on top is not 0, that means the limit does not exist. So you say, so the limit does not exist. The end. All right. So this is. I hope you're seeing what I said before. If you start off and get 0 over 0, that actually doesn't mean anything. Maybe the limit exists. Maybe the limit does not exist. In this example, the limit did not exist. All right. One last example. We're going to see this fairly often, actually, over the next couple of times. Sometimes you're going to have like extra variables inside of your formula that you're taking the limit of. Here's an example of that. Let's do limit h goes to 0 of 2x plus h squared minus 2x divided by h. Sorry, this is not what I meant. I want 4x squared here. All right, there we go. What I said was, this is an example of sometimes you have just an extra variable that's just thrown in there. What do you do with the x while you're trying to take the limit with the h? Here's what you do. You leave the x. And it'll be in the answer, all right? X will appear in the answer. So you don't really do anything special. All right? I mean, you might feel a little weird about it, but there's no problem. It's kind of a pain that you won't be able to say exactly what that thing as a number is. You just got to leave it as an x, and your answer is going to have an x in it. That's what's going to happen. All right, let's do it. As usual, we're going to start off by trying to simplify here, because this is a complicated thing. Actually, you could just try to plug in the h equals 0. Would you mind if I just talk it through? What happens? Well, you get 0 on the bottom, all right? What happens if you plug h equals 0 on the top? You're going to end up with 2x plus 0, so it's really 2x squared. But 2x squared is actually 4x. 2x, the whole thing squared, right? The parentheses are important. 2x, the whole thing squared, is the same as 4x squared, so you're going to get 0 on the top and 0 on the bottom because h is 0. So you're going to have to go back and simplify rather than trying to plug in immediately. How do we simplify? This actually looks similar to the first one we did, so we're just going to do the FOIL thing right there, all right? So it's still limit h goes to 0, because I'm not doing the limit yet, I'm just simplifying. And on top, we're going to do the FOIL here. This, you could work this out on the side if you want. 2x plus h times 2x plus h, right? On the front, you get 2x times 2x, which is 4x squared. On the inside, you get h times 2x, so that's plus 2xh. On the outside, you also get 2xh. And on the end, you get h and h, so that's plus h squared, right? Okay, I also have this from before, so all that is from that part. We also have minus 4x squared from before, and then on the bottom, h, all right? Don't confuse yourself over here. Okay. All right, let's keep going. Try and cancel or whatever. What can you cancel or combine anything up here? I think you can. The 4x squared and the 4x squared can straight up cancel, right? Because I got a positive 4x squared, a minus 4x squared. What else can you do? I can combine the 2xh and the 2xh. That'd be a 4xh. And then this plus h squared, you can't really do much with that, divided by h. All right? Now what? Now everything on top has a h as a factor, right? 4xh and the h squared. So I can factor out h on the top. This is a pattern that you will recognize as we go on with doing these limits. They typically will end by you factoring something out on the top and then canceling it on the bottom. I'm factoring out the h. So it's like this. H times, what's left when you pull the h out? 4x here and h here. 4x plus h, like so. On the bottom, h. Now we cancel the h's. What do you say? 4x plus h, right? That's what's left over. So lim h goes to 0. 4x plus h. Now, finally, we can take the limit by plugging the h equals 0. And nothing bad happens. You just get 4x plus 0, which is 4x, and that right there is the answer. All right. Are you nervous that there's an x in the answer? Don't worry about it. Remember I said, you just leave the x in there and the x will appear in the answer. That's how we do it.